I think the tuner is now repaired. We've changed the resistors, I've checked all the coils, I've looked around, cleaned all the contacts. So that has been set aside until later when we'll go ahead and stick it back in this little box here. But first I want to clean up the box. We'll get to that after a while. But right now I wanted to show you what I did with the horizontal output transformer. The horizontal output, maybe you can see it better without this light, I don't know. The horizontal output transformer, this wire here that goes to the horizontal output tube, it was very, it wiggled, the wire wiggled around so easy, and it was so close to where it went into this wax covered coil, this wax covered transformer, that I was very concerned that it might break off right there. If it broke off right there, right where it goes into that coil, I'd have had a big time problem. It was very flexible, and I was very concerned. So I took some of that liquid tape and I surrounded it and built it up with liquid tape. But a couple of times I just kept putting it on, letting it dry, putting it on, letting it dry. And now the flex point for this wire is out here. It's not here where it goes into the transformer. It's out here. See it? This here is nice and solid. Now there were a couple of cracks in the wax, and I went ahead and whatever I had left in the brush at the time, I went ahead and coated it. And I'll have to put a little more on. I see another crack right there, and there may be one way down under here, I think. So I'm going to have to eyeball that later. But my initial concern was that wire flex point. It has now been out here about 1 inch instead of right there, and I'm kind of happy about that. So let's move on to our next chore. I would like to have everything done on the top of this chassis by August. I don't know if I'm going to make it or not, but that's the task. And then beginning in August I can flip it over and go into the bottom. The next task we're going to do is we're going to restuff these two filter capacitors. They're 150 microfarads apiece. So what I'm going to do is I have a couple of 100 microfarads on hand and a couple of 47 microfarads on hand. I'm going to go ahead and put those in parallel and stuff them into these cans. And then bring the leads up through the bottom, up here and here. Even though see, these cans are upside down, the bottom is actually at the top. I'm going to cut a hole in the center, bring the wires through, solder them where they're supposed to go. But in order to do that, I don't want to do this with it on the chassis. So we're going to go ahead and remove this bracket. I'm going to unsolder these wires and label each one. This one here will have the label put on it of the choke. That goes to the choke. And then these two will have the label on it. It'll say M1, since this one's an M1, and this selenium rectifier is M1, this selenium rectifier is M2. I'm going to put the negative side of M1 here, and this one here, coming from beneath the chassis, goes to a ground, a chassis ground here. And this one here comes around and hooks here, which is a positive. This is not a chassis ground right here. This one is because it's soldered to this frame. Now I could remove these capacitors from the frame. The problem is this one's riveted in, and this one here has the tabs twisted and soldered, and if I were to try to unsolder and twist them back, they might break off. Better to just remove the bracket by labeling the wires. And there's 3 screws. Let me get this thing turned around where you can see it again, just to kind of remind you. Once I get the wires labeled and unsoldered, I'll remove these 3 screws, and the whole bracket will come off in my hand. And then I can work at it a lot easier. So I'll see you when that job is done. All of the wires I'm going to remove have now been labeled. I just put a piece of tape on and wrote down what, you can write anything you want on there as long as it'll help you remember where they went. And as usual, these selenium rectifiers have been replaced in the past, as I told you in a previous video, and you can see how poorly right here the solder joint is really bad. So I'm going to have to probably strip these wires back a little bit and put nice fresh ends on them after I'm all done doing what I'm doing and getting ready to solder things back in place. And the wires are now off. The 3 screws are now out of the bracket, and the bracket is now in my hand. I've wrapped a couple of strips of blue painter's tape around the base of each of these electrolytic cans, and we're going to cut these cans at the top edge, right across, all the way through on both of these. Now these aren't exactly the same. I think there's probably about 1/8 of an inch difference, but what I did was take a pair of scissors and just kind of cut the tape in the center, you know, just by eyeballing it, just kind of give it the old eyeball, and I cut enough to go around the can. And then we're going to take a giant hatchet or a chainsaw or something and cut open these two cans. It turns out I didn't bring my axe or my chainsaw, so I guess what I'm going to have to use is my Dremel tool and a cutting wheel. And I'm going to cut right along the top edge of that tape as far as I can go on both of these. And then I'll have to finish it up with this handheld hacksaw blade and this little handheld dealie here. It's going to be slow and tedious, but these are aluminum and they cut very easy. And then I'm going to have to cut all the way through it. That's what takes the most effort, is cutting through the capacitor itself. Well, there's one of them. I cut partially through, as you can see in the other one, with the moto tool, and then use the hacksaw the rest of the way. You know, it's not easy. You got to cut it through. Take your time, and eventually you'll cut right through that whole thing. Now I've got to remove this, and I've got to remove the center of that. It's fairly even, not too bad. Sometimes you know, you cut and it winds up being like at a slant or something. Well, don't have a heart attack or stroke over that. Just do the best you can, because you're going to wind up taping it all back together again anyway, and it's not even going to be noticed. Cutting these cans open causes the edges to have very sharp places on them. Before you go any further, get yourself a file. I know you're not supposed to file aluminum, but I do it anyway. Smooth the edges down with a file, or get yourself some sandpaper and just kind of knock off those burrs and sharp things, because they will cut your fingers open. Be very careful. You not only have to do it here, but you have to do it around the edges up here too. This was the theory for removing the guts out of the can. Take a wood screw, a long one. This is a long one. I've run it all the way down into the can. And you know, the idea was to take a pair of pliers like so and just pull it right on out of there once the screw got a good bite all the way at the bottom, which it has. Well, I went ahead and took the pliers and I wrapped my hand around the can and put the screwdriver on the shaft, or the pliers on the shaft of the screwdriver, and I pulled and pulled and pulled, and that booger will not budge. Well, you may run into this in the future. You never know. You know, how do you get that out of there? Well, when you run into a situation like this where the screw does not remove it, there's only one thing you can do after you gave it your best shot. You've got to take your cup of coffee, see, like so. And you got to reach over and you got to grab one of these little sugar donuts. You got to dunk it in the old coffee like that. Yeah, that's what you got to do. Yeah, that's what it's all about. And this will kind of help you come up with a good idea for getting that thing out of there. Let me see if it improves my brain thinking ability here. Oh yeah. Yeah, I think I better try one more here. Try one more dunk here. I love these things. One more bite here. I feel an idea coming on. Oh yeah. Okay, I think I got it. I think I know how to now get that thing out of there. So here's the idea. I'm going to go ahead and hold that screw in one hand with the pliers. I'm going to use the heat gun. I'm just going to warm it up a little bit. Now, we don't have to cook this thing. We don't have to heat it till it glows red. And it'll loosen it up. It'll melt it. It's the wax that's holding it in there. It's just wax and aluminum foil wound very tightly. And once we get done with that one, then we'll go ahead and run the screw down into this one and do the same thing. Now, these over here are so thin. I mean, they're not very deep. And I know from experience I can go ahead and dig down in there with these needle nose pliers and get a hold of some paper and then just start pulling it out, and it'll just basically uncoil both of them all the way out. So let's get the first one out of here. Well, the idea worked, you know, the old donuts never fail. However, that thing was put in there using some of that thermal wax, that black thermal wax that you find in Philco Bakelite blocks. The same kind of stuff. Never seen that before inside of a electrolytic can. All the way down in there. There's quite a bit of it in there. I don't know if you can see it in there. But that's what was holding it in, keeping it from coming out. So I had to soften that up with the heat gun. Now we'll do the second one. Alright, the second one is out, and you can really see that black tar-like substance. It's actually a thermal wax, I think, of some sort. They really gooked it in there on that one. Well, that black thermal wax apparently is extended all the way to the bottom of the cans. So I'm going to have to, use the same method for extracting this little shallow section out of that can as I did the larger section. It just doesn't want to let it go. So I'm going to heat them both up, run the screws into this one when I'm done with this one, and just pull them out. I believe we've come to a stopping point for now on this restuff effort. These capacitors, these 100 microfarad 450 volt capacitors, I can't fit one of these and one of these in parallel in these cans. It's just not going to fit. So I have, a couple of options here. I could put the 100 microfarad in there, seal it up, and then mount this underneath and bring the wires up and mount them in parallel, which would give me 147 microfarads. I need 150, but that would be plenty, close enough, no sweat there, especially since it's a modern cap. Or I can mount them both underneath the chassis, which I don't want to do. Actually, I don't want to mount any beneath the chassis. I want them to be inside this can after I clean it out a little bit. It needs a little bit of cleaning on the inside, both of them, which I will do. I also have another alternative. I could go on the internet. I know where I can buy 150 microfarad capacitors, 450 volt, but unfortunately they're made in the United States, which I like, but unfortunately they're $8 a piece plus shipping. I'll tell you what, $8 a piece plus shipping right now. I don't think that's a good buy. The last alternative I have is to go on eBay and pick up some 150 microfarad 450 volt electrolytic capacitors. Foreign made brands, which I think is probably what I'm going to do. And I only need 200 volt maximum working voltage on these caps, but I'm going to go ahead and get 450. I can pick up a couple of them, 150 microfarad, 450 volts for about $4. And that's a long ways from almost $20. Yeah, I just hate to spend $20 on two capacitors. It just seems kind of crazy to me. So we'll end the video here, and I'm going to think about this for a little while longer, and maybe I can find an alternative. I don't know. Anyway, that's it for now. We'll go ahead and wrap it up, like I said, and until next time, thanks for watching. This is John.